All right, two sample t-test with SPSS. So I've set up a data set here. You know how to do that by now. And it's got two groups of, I think, 10, group 1 and group 2. And group 1 is the control group, and group 2 is going to be the experimental group. It's good best practices, they usually say. I hate that term, but to always use numerical variables when you can. Take a look at this, though. You can actually label your data sets, your variables. So what I've done here, as you can see, is I've labeled one as dv is dependent variable, that's the score, and the other one is the group that they're in. And if you click on the little dots there, you can see that I've already set this up, that you've got labels for group 1 is control and group 2 is experimental. Okay. This is useful for output. It just keeps things straight. Right now it's pretty simple, but if you got a complicated data set, it might make sense to do this. And it's good practice, good habit to get into. So now we're going to try to find the effect. Is there a significant difference between the two? So we go to compare means, we go to independent sample t-test, which is what this is, and it'll come up. There you go. And you can see I've already set it up. So let's just revert it back to what it would have looked like had I not already done it once to make sure it worked properly. So we've got the grouping variable and what we're testing. And of course we're testing the DV, and where the grouping variable is, well, group. But you have to, this is one thing, sometimes you get stuck and you have to realize you have to do this part here. Just say 1 and 2, or 0 and 1, or whatever the heck you're using, and do it. And then eventually it should come up. I did this on a dual screen setup, and it turns out my analysis was on another screen, so I had to go drag it over. So you'll see it'll come over here in just a second. And let's see, I was looking for it at this point. I'm looking for, where the hell is it? Oh my God, is this taking forever? This computer is so slow. I hate everything, all people and all things. Oh, here it is. So you'll see now that there's your output, and it tells you if there's a significant difference or not. If the variances are the same, which we assume they usually are, we end up with 18 degrees of freedom. If they're not, you notice how you get this partial degrees of freedom, which is probably a more accurate test. But most people don't use that. Anyway, it's pretty straightforward. I want you to play with this. I want you to have as much fun as you can with something like this. And this is not that bad. You can do it, and it's useful for, you know, doing assignments and things like that. On that note, I guess I'll see you next time. I want you to, as I said, try this on your computer at home. And you can do it by hand if you want, I guess.